So we just exported our elevation correction, and now we're going to look at two of our culverts and convert them into the generalized culvert equation so that you can see the difference between a model that's run with a rating table and the model that's run with a generalized culvert equation. So let's take a look at this. What we typically do to get a rating table is to set a culvert or to set a system up in HY8 and calculate the flow through the culvert and then apply that here as a rating table. The rating table data comes from HY8. So instead, we're going to change this structure, which is culvert 009. We're going to change this structure into a generalized culvert equation. So we need to start by changing this to culvert equation. And then when you use a culvert equation, you need a culvert length and a culvert either box height or circular diameter. So let's take a look at this culvert in the hands-on guide, which is this comes from the hands-on class that you take live. And you can see that we have a square socket and 3 barrels, and I know that these are 48-inch diameters because I know that's what the as-built said. So this picture is taken from kind of like a Google Earth Pro that has the LiDAR into it, so you can see the opening of the culvert, so that's pretty cool. And so we are going to set this up with these dimensions in here. So wait, sorry, let me grab that again. It was 4 feet diameter, 3 barrels, square socket. Okay, so let's just grab, first let's grab, so we know this was 48 inches, right? So 4 feet. So we have to convert that to feet for Flow 2D. And we need the culvert length. I'm going to get the culvert length from my measure line tool, and I'm going to set this to feet. And we'll just measure from this side of the head wall to this side of the head wall, or you can grab that information off of the 250 feet, or you can grab that information off the as-built. So that one is 250 feet, and I don't have a head reference elevation for this culvert because the flow starts flowing through the culvert as soon as it hits the invert elevation. Now if there was some kind of an additional head that would have to be exceeded before it could start filling that, like a weir or something, then we would probably use a head reference elevation. Okay, let's see. Now we need to fill in these guys. So we know it's 3 barrels. We could see that from the view of the picture. We know that the cube base is not needed because it's not rectangular. This would be the culvert entrance loss coefficient, and this would be the culvert N value. So let's say 0.018 for our N value. Our entrance type and our type C are defined in the Flow 2D user manual. But I think I have that also here in the thing. So we got I put it to 252. So 250 or 252, 4 feet diameter culvert equation. And then it says type 2, it's a circular, so that type C becomes 2. Entrance type is 1, meaning that it has a square edge with head wall. And the culvert N, 0.018, and the K rate is 0.5. The base is 0, so it looks like we do want to put that in, and the multiple barrels are 3. So let's go see why these values are 2, 1, 0.5, 0. Okay, the ones that we missed. So that was 2, 1, at 0.5, nope, 0.5, and 0. So we want to, if that's 0, it just will not be used. Okay, next is to go to the next page to look at the tables. And this table, these two tables are going to come from the data input manual, where the switch position for type C, 1 is a box and 2 is a circular pipe. So as you can see, we set ours to 2 for circular. And then for pipe entrance type, One would be a socket edge with a head wall. Square edge with a head wall. Two would be socket end with a head wall. And three would be socket end projecting with no head wall. So we have a square edge with a head wall. So we used entrance type equals 1. Our culvert end value was 0.018. You can probably also get that out of the HY8 manual. This comes from the HY8 manual table, and I believe that this is called Table C2 from the Hydraulic Design of Highway Culverts HDS 5 3rd edition. And you can see that for concrete square edge, the loss coefficient is 0.5. And that's what we have here. So that's where we get these variables. Now we're going to do the same thing for Culvert 122. All right, where are you, Culvert 122? Okay, so kind of the same thing. Back in our document, we should see that Culvert 122, it talks about the elevation, it talks about the levee. We already did all that. The length, it says the length is 100. And what else do we have here? Oh, it's a square box culvert that is 5 by 8. So in this one we have a height of 5, a length of 100. So that's what goes here. But remember, for the box culvert, it's a height, not a diameter. And then let's go set those variables now. So that was changing this to culvert equation. And this is still 0 because we still start to share water to this culvert at the invert of this grid element. And this conduit length was 100, which we can confirm that here. Yep, well, I have 108, so whatever you want, 100 to 110, your choice. And then we'll close that. 100 here. This said to be 5 feet was our culvert height. And then we'll fill out these variables. So the culvert type, we know it's a box culvert, so we know this is 1. And we'll look at what our entrance type is and why here. Our culvert end, we can still use 0.018. Our K rate might be different. And our Q base was 8 feet. And we have only one barrel this time. And you can kind of see that from here, only one barrel. And here's that scupper. You can clearly see this scupper from up here. Okay, so now let's go down here. So type 1 is a box culvert. Type 1 entrance is a wing wall 30 to 75 with a square edge at the crown. Culvert N is 0.018. Culvert K rate is 0.4. The base is 8 feet and there's only one barrel. So let's put the rest of these values in. So this one is 1 and this one is 0.4, and then let's go see why we selected those values. Okay, so type C was 1 because it's a box culvert, and the box entrance types are wing wall flare 30 to 75, wing wall flare 19 to 15, wing wall flare 0. So we had a wing wall flare 30 to 75 degrees. And our box culvert K rate, from the highway manual, is wing wall at 30 to 75, barrel square edge at crown, gives you a 0.4 entrance loss coefficient. So we could, or it could be 0.2 if there's rounded on 3 edges. I don't really think it was rounded anywhere, but we'll just say 0.3 or 0.4. You can't really tell from the image how rounded it is. Let's see if we can go back to the previous page and see. Now it doesn't look super rounded. It doesn't look, so it looks pretty square. Okay, so that defines those, and then let's see. We already set up our weir, and we already set up our elevation correctors. We did that in the previous lesson. So now we should be able to just check those and make sure that their values are still appropriate. So that's these and 2, 1, these are fine. And then we click schematize the structure again. And now I click OK. Now I'm going to export it, and I think my run here is both my runs here are finished, so let's close those runs. Okay, so both those runs are finished, so we can now export this into its own folder. So we click Import Export, Export DAT files, and we'll call this one Generalized Culvert with Elevation Correction. Whoops, let's do this first. Okay, Gen Culvert with ELEV correction. Okay, and let's go ahead and go through that process to export the project and the storm drain system. And now let's run it and see if it will run. Run flow 2D, and that's in the right spot. And now the next thing I'll do is I'm going to finish this video, and then the final video will be called summary. So before I finish this video, why don't we go ahead and just save the project, and then we'll close the project and make a backup after I close down the video.